about the
Yes.
case where we know the velocity just here and we are going up the incline, okay? And we want to determine the total distance traveled on the incline. So here it's very simple. We know the inclination. As we said here, we need the angle because we need to relate h and d through this angle. So we know the velocity at this point, and we know that as we go up, since no friction, we have conservation of mechanical energy. So the kinetic energy will be transformed into potential energy, gravitational energy. And this gravitational energy can be written as plus mg times h, where h is the difference in height between the initial level and the final level here. And since h can be related to d, this will allow us to get the value of d. So we replace h by d sine 35. And then we simplify the mass m to get what is the value of d. Okay. So let us move to problem 3. The third problem I sent.
بس
Yes.
بس سؤال صغير
نعم.
إذا استعملنا كمان الورك اند انرجي هي ذاتها ما هيك
أكيد هي
يعني
ذاتها.
بيطلع نفس
ما
الجواب.
في غير الورك اوف
اوكي
ويت. والورك اوف ويت فيك تجيبه ب two methods, or minus mg delta y, او you project the weight on the direction of motion بيطلع minus mg sine 35 and you multiply by d. So whatever you do, you will get the same result.
Okay, thank you.
Welcome. Okay, so please look at the third problem I sent you. In the third problem, you have a car is moving around a bend which is banked at a constant angle of 10 degrees to the horizontal. When the car is traveling at a constant speed of 18 meters per second, there is no sideways frictional force on the car. The car is modeled as a particle moving in a horizontal circle of radius r in meters. Calculate the value of r. So here, it's very similar to the Formula 1 problem we did together. So just you should draw the corresponding picture and you will see that it's very simple to solve. So what we have here, we have a car moving on a certain round, around a circle, horizontal circle, but it's in contact with a banked surface. Okay, so you have this, you have a banked surface and the banking angle is given to be 10 degrees. So it's exactly the Formula 1 problem we did together, if you remember it. And in this problem, we should deal with UNUT coordinate system. Okay, so I consider the car is treated as a particle. The forces acting on it are the weight and the normal. And since it's doing a circular motion, so if I present the motion, it's moving around a circle, a horizontal circle, okay, of radius r, and I want to calculate this radius, okay, knowing just the value of the banking angle and the velocity. So this is my radius to determine. I don't know what is the value of the radius. They gave me the value of the speed. So I know that my car is moving at a constant speed of 18 meters per second. Okay. So always, as I told you before, whenever you have circular motion, think about applying a Newton law in normal tangential coordinates. So the first step will be to represent these coordinates on your figure. How is UN here?
Towards the center.
Yes, always UN is towards the center. You have UT is tangent to the path, and you have UB that is vertical because it's perpendicular to the horizontal plane. Okay, so this is UB, this is UN. Here it's a 3D presentation if you want, but إذا بناخد the profile view, UT is a point because it's directed towards us. It's perpendicular to the screen. Okay, so you can see that all your forces are within plane U and UB, the normal and the weight. So when you apply Newton law, you will not have any projection on UT, and this is expected. Why? Why it's expected that sum of forces along UT is 0?
لأن velocity is constant
Yes, very good.
والacceleration 0.
Very good. The velocity is constant. This means that AT is 0. So I can predict that sum of forces along UT is 0. Okay. So I will not need to project along UT. I have to project along UN and UB. Okay. So if I want to project on UN first, what are the forces having projection on UN? So I will draw the forces again on another figure to be clearer. So you have the normal, this is N, this is W. And if I want to present UN and UT, this is UN, this is UB, and UT is perpendicular to the screen, okay? So this is my UN, this is my UB. And as usual, UT perpendicular to both. And here I can present it in this way. And this is my normal force, and this is my weight. In order to do my projections, I need to determine the angle between the normal and UN, or the normal and UB. How can I find this angle? What is the angle between N and UB? It's equal to what?
45.
No, it's equal to this angle here. Why? Because look, the normal is perpendicular to the incline, and UB is perpendicular to the horizontal. Okay, so because these two lines here, which are N and UB, are perpendicular to the inclined and horizontal line, so the angle formed by these two lines is similar to the angle formed by these two. So this is equal to the bend angle here, the banking angle, okay, which is 10 degrees. If you don't remember the method of two lines perpendicular to two others will have same angle, you can do a small interpretation on the figure. Let me draw it again. You have the following. You have, this is the incline. This is 10 degrees. Okay. And this is the normal. The normal is perpendicular to the incline. So it's along this direction. Because the normal is perpendicular to the incline, so this is N. Then I know because this angle is 90 degrees. Okay. And this is 10, so this angle will be 80. So the normal is doing with the horizontal an angle of 80 degrees. Then with the vertical, it will do 10 degrees. Okay. Because the vertical and the horizontal are perpendicular to each other. So you have complementary angles. So if N is doing with the horizontal line 80, this means that it will do with the vertical line 10 degrees. So you go back to the result that the angle between N and the vertical is equal to the angle between the incline and the horizontal. And then you are ready to project your forces along UN. Because as we said, this is UN and the vertical is UB. Okay. And you have as forces along UN, the only force is N, projection, because the weight is vertical. So this is the weight. It doesn't have any projection along UN. So when I project on UN, you have the following. You have plus N or sine 10 or cosine 80. So both give you same result. So you can do N sine 10 equal, you don't have anything else, equals to mv square over the radius. The radius is unknown, okay? And v is known. And the mass is not given, but no problem, because we'll see that the mass will cancel out. So this is relation 1. Relation 2 is sum of forces along UB. So this is sum of N equals MAN. The second relation to use is sum of B equals MAB. And you know always that AB is always 0. Because when we define normal tangential coordinates, we said that no motion along UB. So always sum of forces is 0 along UB. And if I project, then I get that N cosine tan minus the weight equals 0. So if I take the weight to the other side, I get that equation 2 will give me N cosine tan. And you know how to proceed, okay? How to get the radius R? What should I do? To cancel out N, what should I do?
N equal mg over cosine theta بتروح
Okay,
الآن
and I replace,
بترجعنا
or if
2.
you want, you can divide equation 2 by 1. So if you divide equation 2 by equation 1, you will have that N will cancel out, okay? And then you will have cosine 10 over sine 10. M will cancel out also. So N will cancel out and M will cancel out. So you will get equals to GR over V square. And since your unknown is the radius, you express the radius function of the velocity. So the radius is equal to V square over G tan of 10. Okay, the velocity is given, it's 18 meters per second. So you replace here by 18. You can use G10 and then you can get your radius in meter. Okay, your radius will be nearly R equal 184 meters. Okay, any question on this problem? Okay, we move to another problem. Let me check the first one I sent you. Okay. Now you have in this problem a curved path. So you have motion on a curved path. In figure 3, you have the path of a skier of mass 70 kilogram moving on a ski slope A, B, C, D. The path lies in a vertical plane from A to B. The path is modeled as a straight line inclined at 60 degrees to the horizontal. From B to D, the path is modeled as an arc of a vertical circle of radius 50 meters. And the lowest point of arc BD is point C. You can see the figure on the photo I sent you on WhatsApp. Okay. They want from you to calculate first the speed of the skier at C, the normal reaction of the slope and on the skier at C, and the speed at D. This is the first 3 questions. Let us draw the figure and do the analysis step by step. So you have first a skier moving first on a straight line. This straight line is characterized by an inclination of 60 degrees. Then, so this is the first part of motion. It's a rectilinear motion. Then it will move on an arc of circle of radius 50 meters, okay? In a way that, so you have the bottom point is, the lowest point is C, and you have D here, okay? Sorry ما كتير ظابطة الفigure, but you can check it, the real figure on WhatsApp. So this is point A, the beginning point. This is point B. You know that this is an arc of circle, and this arc of circle is of radius 50 meters. So this is 50. And the lowest point reached on this circle is at point C. Then you will move up to D. D is nearly here. But D, look, D, from the figure, D is below B. So you will stop somewhere here, okay? So arc of circle will end at D. And after D, you will overgo the projectile motion, I think. So after D, you have, your path is over. So let me change the color. So this is, we'll cancel it, يعني. You will have a certain velocity here, and this will give you a projectile motion, and the angle is 30 degrees, okay? Now, what is the information that we know? We have the mass of the skier is 70 kilogram. We know that the speed of the skier at B is 20 meters per second. So when we reached B here, the velocity at B was 20 meters per second. Okay, and we want to, what do we know also? We know that the path is inclined, at D, the path is inclined at 30 degrees to the horizontal, and the skier is moving upward. So still we have a path here, but it's inclined. It's a straight line. And here it will continue as a straight line after D. Okay. Now, they want us first to consider that the whole slope is smooth as a first step, okay? And we want to find the speed of the skier at point C. So we need to determine at the bottom point here, what is the velocity of the skier? Okay, so what should we do here? So this is, C is the vertical point, is vertically below the center, okay? And we have that this distance is equal to the radius of the circle is 50 meters. What will you apply between B and C to find the speed at C? What should we use here? They said that the path is smooth, so you don't have friction, okay? So you have conservation of mechanical energy. And you can determine the variation in height between B and C. You need to use some geometrical relations. You know that here the angle is 60 degrees, okay? And you have an angle here of 90 between the incline and the radius. So this angle here will be 30 degrees, okay? So this will allow you, knowing this angle, will allow you to find the difference in height between points B and C. Okay, so this distance h can be calculated as h equal to the difference between this height and this one, okay, this part. As you can see, this part is in this right triangle. So this height here is 50 sine 30, okay? And the whole height is 50. So h will be equal to 50 minus 50 sine 30. And sine 30 is 0.5, okay? So you can say then that I can calculate the difference in height between B and C. So H is 50 times 0.5, it's 25 meters. Okay. Once you find the difference in height between B and C, now you are ready to apply or conservation of mechanical energy or work and energy. Both will work. You can consider that this is the reference of gravitational potential. Point B is the reference. Since B is the reference of gravitational potential, then you can say that at B the gravitational potential is 0. So 0 plus, you know the velocity at B, so plus half mvb square equals to, at point C, okay, you have gravitational potential energy and kinetic energy. Since point C is below the datum, below the reference line, it has a negative gravitational potential energy. So you have minus mg times h and plus the kinetic energy at C. So plus half mvc square. As you can see, m will cancel out. No need to. So here m will not affect the value of velocity at C. M will cancel out, and we have already calculated h, and VB is given, so we can find the value of velocity of the skier at point C. Now, we move to the second question. They want us to find the normal reaction at C. Okay? If we want to calculate the normal reaction at C, what should we use? Which equation? How to calculate your normal here? If you draw the free body diagram, always when they ask for a force, you should draw the free body diagram. If you draw the free body diagram at C, you have the normal reaction. Because C is at the bottom here, then at this level, the normal is vertical. Okay, because the tangent line is horizontal and normal is perpendicular to contact. So the normal is vertical. And you have the weight. And since it's a smooth surface, no friction. Okay, so here we can just apply Newton law, and since it's a curved path, we'll apply some of forces along UN. UN here is upward because the center of curvature is here, so UN is always directed towards the center of curvature. So we can write that sum of forces along UN equals MAN. And since we are interested at point C, so we'll apply some of normal forces at C. So we have plus N at C minus the weight, which is mg, equals to mvc square over 2. We already calculated the velocity at C, over R. We have the radius of curvature is 50, we replace. So we know VC, we know R, we know the mass, we can get the normal at point C, okay? So the normal at point C is mg plus mvc square over R. And we can demonstrate that this is the highest value of normal because at this point, the velocity will be the highest, okay? Plus, the weight is completely projected on UN. Yani the maximum projection I can add of weight is plus mg. So we can say that N at C will be maximum. Okay. Now, the next question is to find the speed of the skier at point D. Okay. So if we want to find the speed of the skier at D, we need to determine also the height of D. So if we use some geometrical analysis, you have here an angle of, so this is 30 degrees, okay? You have this angle is 30. And then if you consider the radius here, okay, these two lines will be perpendicular. Okay, so we have here, so this is 90 degrees and this will be 60. So similarly, as we did for this point, we can do same analysis to get h of d, and we apply conservation of mechanical energy or between B and D or between C and D. Okay, so both are right. Okay, so just we apply conservation of mechanical energy to get the velocity at D. Of course, we expect that the velocity at D will be larger than the velocity of B because it's at a lower level, and it will be smaller than the velocity of C. So VC will be the highest one, followed by VD, followed by VB. Now, in question D, they told you to determine the change in the normal reaction as you pass through B. Why we will have a change in normal reaction as we pass by B? Any idea? So at B, when you were moving on the straight line, just before reaching the circle, you have a value, and B before if you want. And just after reaching the circle, you have another value of the normal. This is due to the change in curvature. Okay, so as we discussed before, on a straight line, the curvature is infinity, while when you go through the curved part, the radius is 50 meters. So this will affect the value of the normal. If you want to do an analysis of this, we can just first start with the straight line. For the straight line, which is doing an angle of 60 degrees with the horizontal, if we plot the free body diagram, okay, we have the weight and we have the normal, and we already said that since we are moving on a straight line, okay, then radius is infinity and sum of forces along the perpendicular to the incline is 0. So at point B, before reaching the curved path, we can call it, if you want, this is NB1 and the other one is NB2. Before reaching the curved path, I can write that I should project along this direction, and I say if this is Y, if I call it Y, I have sum of forces along Y equals to 0. So I have, as we said, this angle here is 60 degrees. Okay, so this angle here will be 30. And the weight then is doing with this direction an angle of 60 degrees. So if I project the weight on Y, I have plus MB1 minus mg cosine 60 equals to 0. So for the first part, I have that the normal is just equal to mg cosine 60. Now, what will happen as I move to the curved part, okay, the normal will increase. Why it will increase? Because now I have the effect of the curvature. So as I move to the curved path, at this point now, I cannot say sum of forces along this direction equals 0, because now this is UN and the radius of curvature is here and is equal to 50 meters. So in the second part, I should put UN vector. So this is UN in the second part, it's directed towards O. And then if I apply sum of N equals to MAN in the second part, I have that I have the normal is already along UN. For the weight, same thing. When I project the weight, the angle is 60. So it's minus mg cosine 60. But now the difference is from the other side. It's not 0. It's equal to mv square over the radius. And now the radius is not infinity. The radius is 50 meters. So it's mvb square. Vb is given over 50. So you can conclude that the normal will increase. So nb2 will increase by mvb square over 50. So if you do delta n b, which is nb2 minus nb1, you will have an increase in normal due to the effect of curvature. So nb2 minus nb1 equals to mvb square over 50. Okay, any question on this? So we still have just one question in this problem. They told us if we consider that we have friction, okay, consider that you don't have smooth surfaces, you have friction. They just want you to determine how your answer in part B, okay, will be affected. So they don't want you to do calculation, just to do some interpretation. So if you have a friction, how the normal reaction will be affected at C? If you remember, when we calculated the normal at C, okay, we obtained that N of C is equal to mg plus mv square over 50. M times Vc square over 50 by applying a Newton law. So here we just want to do a qualitative interpretation without calculation. They told us if we have friction, what will happen to the normal? So if we have friction, this means we have loss of energy. If we have loss of energy, this means Vc will be reduced. And since Nc and Vc are proportional, so if Vc will increase, Nc will increase, then a decrease of velocity at C will lead to a decrease in the value of the normal. So we can just say, because the friction will lead to loss of energy, this will reduce the velocity at point C, and therefore this will lead to a reduction in the normal at point C. Okay, so this was the first problem. We still have one problem. We'll continue it together next time. Thank you.